Everyone can see my screen?
Yes, sir.
So let's start with DevOps. Now, when we talk about Azure DevOps, before that, we'll talk about what is DevOps. Okay, anyone? What is DevOps?
Development.
Mhm. Only
Web app.
development.
Developing web app.
Mhm.
Or development
Development
application.
plus operation.
Development and
Applications.
Operation.
Yes,
Both
development
plus
plus
operation.
operations.
It's called dev.
It's an
So, think it is combinedly people coming together. Okay.
Yes.
People coming together and working on a unified process.
Right.
And also, you can say that DevOps is also implementing automation for development of
So in general, DevOps is a collaboration of development and operations
operations.
with the help of automation.
Yes. This is also one definition. Okay. So DevOps is altogether like people coming together and working and following some unique process. Okay. Now what happens earlier? Say there are developers. Okay. They were developing or writing the source code for something. They are developers. Now at that time, what happened? Like developer is there and he or she writes some source code. They're writing the source code here. They're developing something. Okay. And they're developing something, writing some source code over here. Okay. And they're testing. They're testing. Say this developer is having some environment, some system. Say they are having Mac or something. Okay. Mac OS. They are working on that. So they are developing any application, they are testing it in their environment. And then what happens? They push the code somewhere in the central repository. Once tested, they push the code to code repository. Okay, now code repository we'll talk about later. How many types of code repositories are there? Okay, so I'll just say code repository. So once pushed to the code repository, now who will come into picture? Testers, right? So developers have done their job. Now testers are came into picture. Now they pull the code from there. Okay. Same repository. They are pulling the code. So sorry. After pulling the code, what they will do? Now they have the code and all those things, right? They will write the test cases. Then they will build the source code, and after building, they will also deploy and test. Now, what happens here? Say this tester is having a different environment or a system. Okay. Say he's having some Windows. Now, the same codes, the same source code, which is running in the development environment, here it is successful. Successful. Same code here, it is giving errors. Why it is giving errors? Because whatever dependencies might this developer might be getting or using, the same dependencies and all, this tester guy, he's not getting all those things, because different environment, different environment. Here he's using a Mac OS, here he's using Windows. Maybe there is a difference of some files or anything. So what happens here? The code is not successful, or you can say deployment is not successful. What you will think, what can happen in this scenario? So this guy, he will blame to the developer. Okay? He will say, okay, your code is not working. This guy will say, I've tested my code. It's fault with your system. I'm not responsible for that. Everything is working fine in my system. So basically, that time what happens? A blame game starts. Now, to overcome all these things, because ultimately the business is the one which suffers, right? In that case. So they come up with some process, or you can say method. So from the earlier days, what they were following first. So for developing any application, software development life cycle. SDLC model they were following. Okay. SDLC. Now in SDLC type of model, there were some old models, or you can say legacy models which were used earlier. Okay. So I'll not say old. Let's talk about it first. So when they are developing some application, like there was a product owner, then all these phases were there in the software development life cycle. So these are some phases. So say you have a product owner. Without the product owner, you will not know what to develop. Okay, so product owner. Then when a product owner provides some information, so you are the guys who will be working as a solution architect, maybe, okay, or some senior technical person. What you will be doing? You will be gathering the requirements. After gathering, what you will do? You will perform some analysis. Now this analysis, while doing this analysis, you will write some documents. So these documents are some system requirement documents. System requirements specification. SRS. Then what you will do? Plan and design, right? You will plan and design. After this, there will be a next stage, or you will write the source code. And then test, deploy. There will be last one more. You can call it as a monitoring and support. So, monitoring, support. So here all these things. So who is the main technical person, you can say, who can perform this task, like gathering the requirements and all? It's mostly the solution architect, because he knows the how to design and all. Okay, he have learned how to design. So most of the time, solution architect. Who will be doing all the analysis, writing the documents and all? Again, solution architect. Who will be planning and designing? Solution architect. Now, after the design, developers come into picture. Because they are the one who will write the source code. Then testing team is there. Write the test cases and all. Perform the test on the code. Okay, all those things. Then operations team. Ops. And then there is a support team. Application support. Monitoring and support. So at that time, they were using software development lifecycle. Using that, they are performing these tasks. Okay, and once the requirement is complete, then the analysis are done. Then one by one, they are doing planning and design. Then once the planning and design is completed, they are writing the source code to develop that feature, whatever they are working on. Then after coding, testers come into picture. They will write some test cases and all. Then they will pass it on, and operations team will deploy. Okay, and then once deployed, once released, application is released, then support team will work on the application support. Okay, all these things. Now what happens in this case, there were some we can say drawbacks.
Abhishek,
Now as this is one by one everything is doing, this model was called at that time as a waterfall model. Waterfall model, or you can say sequential also. Sequential, everything is done sequentially. So sequential model. Now here solution architect is gathering the requirement.
who is Abhishek? Who is product owner? I mean, like here you said
Your
the Scrum-
client, your client.
Okay, in the Scrum call, usually product owner is there, right? So who plays it in?
Depends. Not every time. I don't think every time product owner is there. So what happens? I will come to it later.
Okay,
After
sure.
this. Yeah. So requirement, it takes say around a month or 15 days to get them. Okay. I'm talking about time when there was no automation, nothing. Okay. So 1 month to get this, or then 15 days to a month for performing some analysis. And then again, planning and design. Design is a very critical part. So it takes time. Okay. 1 month for this. Then once designing is completed, then the developers come into picture, and then they will write the source code. So again, they will write, they will perform some test, all those things. Now, if it is a big application, it takes time to write code. Okay, so roughly 1 month here, all those things. Then 15 days for testing team, 15 days. 15-20 days to deploy and test in environments, different environments like dev environment, stage environment, QA environment, stage or QA, or you can say later on in the production after successful test and all. So say 15 to 20 days to them also. So what happens, like all these things for developing an application using this model at that time without automation, nothing. So it takes a very long time to develop some application. Say 6 months. Six months it is taking. So if we talk about drawbacks then, so drawbacks were long time to develop. Second thing, no proper resource utilization. So say there is a company, there are different projects and different teams at that time working on some project. So what happens, like 1 month, so say this is one project, one single project. So this is the whole team of the project. Okay, team is having developers, testers, everyone is there, and there is one project of some vendor or some company you are getting, and you are working on that. Now your team starts working, solution architect gathers the requirement, all those things one by one, then performing the analysis, doing planning and designing, all those things. So at this time, when solution architect is working on these things, and this is the team for one project, so developers will not be there in the picture in the time frame when the solution architect is working. So developers will be busy in some doing other things, like maybe they develop some inline they write some code for the inline development and all those things, but most of the time at that time they won't have any work during a project when all these things like first 3 phases are there, like requirement analysis and planning and design. Once these are done, once the design is completed, then only developers come into picture. Then once the development once they write the source code, then testers come into picture. Once testers have done their testing and all, then operations team come into picture. So what was happening at that time? No proper resource utilization. No proper. If solution architect is working, developers have nothing to work upon for any project and all. Okay, testers have nothing. Deployment team have nothing at that time. So one by one, everything is done. So it takes a long time to develop that application and no proper resource utilization. So they come up with another model. So agile model came into picture after that. So now in the agile model, what they did, they focused on the management. They focused on the project management. So again, you will be having some product owner here. So mostly they focused in agile model on the management part, because the management was very poor in waterfall model. So here also you have product owner. Then there's a scrum master. Now scrum master is the team manager or team lead, or whatever you can say. Many times he can be a solution architect also. A solution architect will be a scrum master. Okay, because he is the main technical lead of the team, solution architect. So he can be that. Then scrum call. And then comes the sprint. So again, there's a scrum master. Now here, as they focus on the management, so here focus is totally on project management. So now Scrum Master will work like that. What he'll do? He will perform some Scrum call. Okay, internal Scrum call. He will not include a product owner because he knows what is the project. He has the meeting with the solution architect, business analyst, and all those, and the product owner earlier only. So he knows what is the requirement. So he will perform the Scrum call. Very first thing he will do, he'll check the team availability. So team availability will be in his mind first, very first thing. So developers are there in the team, then testers, operations team. So say you have, for example, you have 10 developers with you and you have 8 testers. You have 4 people from the operations team. For example, just for example, team availability. Now he has the team availability. How many people are from the development? How many people are who will be performing testing and all? How many people from the operations team? So now, as he is focusing on the project manager, now he will gather the requirement. He will take the requirement now. Now, product owner is having some, for example, this is a very good example. So I'm just giving that, some e-commerce application. So now this, as they totally focus on the project management. So what Scrum Master does, like divide the application into features, into small features. Now, for example, these features can be, say, first you have the login page with you. Then you have product page, say. Third, you can have your cart where you add the product. Fourth feature you can develop as a payment page. So small features. So after this, what happens? Scrum Master performs a call with the product owner for the first feature and gathers the requirement and all for the login page. Once this is done, what he'll do? He will again perform a Scrum call. He'll again perform a Scrum call. In this Scrum call, what he'll do? He'll sign some 2 developers here who will write the source code for your first feature, that is login page. Then he will deploy some 2 of his testers who write test cases and all. Testing, basically they will perform testing and all. Then say one from the operations team for deploying login page. That is the first feature. So all this will be done, will be performed in a sprint. And say we are calling this as a sprint 1. Now this sprint is nothing but the time period. Is the time period. So commonly it is of 2 weeks. A sprint is of 2 weeks or 10 days. Somewhere maybe 3 weeks also, but mostly 2 weeks. So is a sprint. Now they are performing or doing all these things in the sprint 1. Parallelly, what Scrum Master will do? Parallelly, Scrum Master will gather the requirement for the product page also. So this everything is working over here. They are doing testing and all. They are performing Scrum calls. They are giving. So in first week they have given whatever the developers develop and all. They have given all the updates to the Scrum Master. Now accordingly he plans for the second sprint also. So in the second sprint also, what he will do? Again, 2 other developers. So they will write source code. They will write the source code for product page. Then 2 of the testers will be there who will write test cases and all. And then 1 from the operations team again, he will deploy the second feature. So product page. So all those things will be there in the, you can say, second sprint. So sprint number 2 is there. This sprint number 2. Earlier one was 1. Similarly or parallelly, you can say they will be working on sprint 3 as well and sprint 4 as well. Now, till this sprint 1 is a success, they will not, you can say, close it, or even they close the sprint in 2 weeks. So whatever is left out in this sprint, whatever is left out, they will move that to the sprint number 2. And they will parallelly working on the product page as well. And whatever is left out with the login page thing, they will work on that as well. Okay, so they will move to the sprint 2, but whatever is left out from the sprint 1, they will perform that thing also in the sprint 2 parallelly. And then similarly, sprint 3 and sprint 4, they will work upon. Now, once all these things are done, combinedly, what they will do? They will perform testing for all the features.
Abhishek,
They will perform testing for all the features, and they will test in the, say, development environment. So there will be different environments. You can say dev environment is there, then stage, or you can say QA also. So before stage also, you can have QA sometimes. Okay, so QA environment, then you can have stage.
Abhishek, here developers will be increased or testing will be increased in sprint 2 if at all some leftover is there in sprint 1.
Yes, definitely they will involve some more developers. Okay, so accordingly they will plan accordingly. Like I told you that he got all the team availability at the first only.
Right.
So he's planning like that.
Okay, plus or minus can be done in each queue.
Yes. So if they want some more developers in the team, definitely they can give the requirement that we want some more developers and all. They can perform interviews and they can have the developers, right? Or either they can, if there are developers from other projects also who are not working at that time, they can also have those ones.
So usually, practically what happens is, let's say there are 10 items on sprint 1 and four remaining to be done. So 4 is left out. So in sprint 2, they will only pick 6 item or 5 item.
Right.
And those 4 leftover item picked in sprint 2.
Yes.
So the in total developer number will be same, but the amount of work, the new work we are picking up in the sprint 2 is less to cover the sprint. This is how usually it works.
That is like practically how it works. Yes, you are correct. So all these environment, like first done in dev environment, then QA. So all those developers and testers will come into picture in developer and QA environment. Once it is moved to the stage environment, then who will perform some tests, like maybe it can be a BA who will see all those things. So product owner will see, BA will see, and Scrum Master is involved in everything, like dev and QA also. So Scrum Master also you can involve here. Okay. Now after this, product owner will be the one who will give you the permission to move the or release in the production environment. Okay, once he is satisfied with the stage environment, what is deployed in the stage environment, if there are any more features to be added, he will say, okay, we have to add this feature, or we have to remove this feature. Okay, all those things. So once he's satisfied with the stage environment, he will give you permission to move or release to the production environment. Okay, all these things. So this is, we will see later in the part how we create the development stage and production environment in the Azure portal. Okay, using subscriptions and all. So there will be different subscriptions. So dev environment will be having a different subscription. QA environment will be having a different subscription, like this. So all these things they perform. So while doing this, they have earlier they have the drawbacks, right? So drawbacks resolved here. Some of the drawbacks. So first drawback was like long time to develop. So less time here, less time to develop, because everything is done parallelly. So less time is half of the time totally from the waterfall model. Less time to develop. Second thing, proper resource utilization. Everyone is working here. Okay. So they have resolved these things, but again, here they have some drawbacks, some more drawbacks they are coming with. So with the agile, so what they were, no automation involved, no automation. Now when no automation was involved, so what happened? You have to perform quick releases here, quick release. Now why quick release? Because you have dev environment, QA environment stage. Some of the features may be left out behind. Okay, some are done, some are left out, all those things. So if something is left out with the sprint number 3 or 4, you have to perform quick releases because time is less. So say you have some deadline from the product owner. Okay, you have to do this. So as a result of that, you have to do quick release, and this quick release will be manual here because there was no automation. So manual, and you know that when a manual process is involved, there are errors. Errors may be in the pipeline and like during the release process. So there may be errors. So to avoid these things, they come up with, they added agile with the DevOps methodology. So DevOps is not a process or something like, or you can say it's a methodology. Okay, it's not any technology or something. So when they added it with DevOps, so what they have done, they have included the automation. They have all the tools, automation tools or DevOps tools, you can say. Automation or DevOps tools. Now, what are these DevOps tools which they integrated? Like first we talk about is version control system. So you can call it as a VCS. Very first and foremost tool to learn while learning the DevOps. So version control system. Now version control system is a, you can have, it's a central code repository, and these can be of two types: central and distributed. So let me write like this: two types. First, central, and second one is distributed. So when we talk about central repository, so in the central repository, what happens? Say there is a developer. There's a developer. There are two developers. Say this is developer 1. This is developer 2. Now they are working on some features. They're writing the source code, and what they will do after writing, since everyone needs the copy of that code in that team, right? Everyone will be needing, testing team will be needing, right? All those things. So what they will do, they will push the code. Okay, so they will push the code. Now this is central repository, so I'll take central repo, and from there everyone will be pulling the code and using it. Now with this central repository, there are some drawbacks with the central repository. Okay, so drawbacks with central repo. So these drawbacks are, if some issue happens with the central repo server, issue with central repo, what will happen? No one will be able to work until the server comes back again, because it's a central. So no one is having, they are just pushing the code and pulling the code from there and working on it. So that is the issue. So if issue happens with the central repo, means issue can be like, for example, server crashes out or any other thing happens. No proper network connectivity to the server. Network, all these things can be the issues, right? So in that picture, no one will be able to access. No one will be able to access. So later on, they come up with a distributed system. Now, distributed system says everyone will be having a copy of the repo in their local. So everyone will be having the whole copy of that repo into the local. So there are two things now. You can have a local repo in your system, and you can have a central repo also. So now this is distributed. Why? Because each and every developer, each and every person is having a local repo also and a central repo also. So whenever you create some project, you initialize that project, say, with that local repo, and then you push the code. So when you initialize your project with the local repo, you have and you are connecting it to the central repo. Once you are connecting it to the central repo, all the things which are in the central repo, you will have a copy of that in your local repo. So you can have copy of central repo. So what happens if there is issue with the server or the network connectivity? Still you are having all the things with your local repo. So you can still work. So you can work in case of central repo server outage. Your work will not affect here. And then you can push the code, you can pull the code from the center, you can perform each and everything. Okay, so this is a distributed kind of repo. So mostly what we are following is this as of now. Still some people are on this kind of thing. So there are examples like SVN is there. So you can have SVN. Here what you have in the distributed, very popular, Git. So Git is there. So local you can have as Git, local Git, and distributed repo you can have GitHub. Can have GitHub. So from the GitHub, there's a like many repositories are there, many branches, many repositories are there in the GitHub. Like from all around the world. They are private also. There are public also. Public means anyone can access that repo. Private means only who are authorized and added as users to that central repo, only those people can use. So mostly whatever we work upon in our organization are mostly the private repos. Means our team can only access that. No other person can access. And whatever the public is, you can find those public repos. Okay. So for example, like if you search for some .NET Hello World project, GitHub. See, sample Hello World.NET Core application. This is a public repository. Everyone can access. I can access this code. I can run this application. Okay. I can have this code. I can pull this code from the GitHub and I can pull it in my local. And I can work accordingly. So see, these are how I can clone this. I can copy this and I can curl this out in my local repo. So I can have my command prompt and from there I can curl this repo. And I'll be copying this whole code .NET Hello World in my local. You can also have like HTTPS GitHub CLI. So there is a CLI tool also for GitHub. You can download that CLI. You can also download the zip file. So if I click this, see, I can download my zip file. Inside, I can have this project folder. Here, I can save my file. So once I download this project, here, the DevOps, the projects, see, .NET Hello World. I've downloaded that code from the master branch. So branching strategy we will learn when we learn Git. Okay. So you can extract here. See all the files, Hello World API, all those files, all the project I have downloaded. Now, once my project is downloaded, what you can do? You can edit anything. You can use, you can say whatever you want, you can use. You can go to this project. You can open your Visual Studio Code. See, I have my project in the development environment here. Now I can edit whatever file I want. YAML file is there. Solution file is there, right? Whatever I need to edit, I can edit now. See, there will be properties file, program CS file. If you want to add some dependencies and all, program CS file you can add, all these things, all the files, startup CS file. So people who are developers, they will be knowing, okay, each and every aspect of this. What are the files? What are they used upon? Like all those things. So you can use this terminal, you can run some commands, you can run the project from here. Like you can use the commands like .NET run, .NET build. Since it is a .NET project, right? You can run this out. So this is the project. Let's go back. Let's close this. So see, this is a distributed kind of repository, Git. And the central repository is GitHub. So this is the first kind of tool. Second, we can have continuous integration continuous deployment. You can also call it as CI/CD. CI/CD. Continuous integration, continuous deployment. Now, there are tools for continuous integration and deployment. In our case, we have say, now here also, as I told you about Git. So you can have Git here. And in Azure, there is an implementation of Git. There is implementation of Git. So that is known as Azure repo in this case. And Azure repo is nothing but the implementation of Git in Azure. So you will push the code in the Azure repo and all. You can keep that code in the Azure repo. Now is the continuous deployment, continuous integration, continuous deployment. So what is there for you? In case of Azure, we have Azure pipelines. Now Azure pipelines, they are still of two types. You can have build pipelines and you can have release pipelines. So build pipelines. So once a developer pushes the code to the central repo, what happens? A trigger is done. So pipeline triggers. Pipeline triggers. Means we are doing a setup like this, that once the code is pushed to the repo, and means after this is done, once the code is pushed to the repo, a pipeline will trigger now. A pipeline will trigger. And when the pipeline triggers, say this is a build pipeline. So what this will do? This will perform some steps. So first, in this build pipeline, I'm talking about Azure pipeline. Okay. So there is an agent. Now this agent is nothing but whenever you run some pipeline, for the background jobs to occur, you need some agent. You need some compute resource. This agent is nothing but the compute service. This compute service can be of two types. You can ask Azure to have the compute service. So Azure will provide you. This is also of two types. First is you can have Azure pipelines, Azure pipeline agent. So in that case, Azure will assign some agent to you, some machine to you, some compute machine, and you don't have to worry about that. What is that? In second case, you can have it yours. So you can have agent VM with you, agent virtual machine. It can be, you can have a Linux VM also. Either it can be Ubuntu or any VM. Can be have Windows, you can have Windows agent also. Agent VM. So you can create a VM inside Azure and you can create, we have seen in the extension, like when we were creating the VM, we have seen in the extension part that even we can use that VM as a pipeline agent. So you can have an agent VM here. So first you have agent in the build pipelines. So this is all the structure what I'm telling you about the pipelines. Okay. So you can write the pipeline like this. First you can have agent. I'll let you know how to write and create a pipeline later. But as of now, roughly I'm telling you. Okay. Pipeline. So first in the pipeline, you will be having agent. Inside the agent, you will be having jobs. Now, first job you can have. Now you can choose number of jobs. What job you are doing, what job you are performing. Say like here, what I'm performing is, I'm performing some job like you can say, I'm before the build, I need some, you can say some dependencies. So like if there is a .NET project, you know, so if there is a .NET, this is just an example. To build a .NET project, you need some packages, right? These packages are nothing but the dependencies. So there are NuGet packages. So people who are developing or developers who knows .NET and all, they know. Okay, NuGet packages. These are nothing but the dependencies. Okay, so job is you are adding up the dependencies. So now inside this, you will be having, inside the jobs, you will be having tasks, different tasks. So in the task, you will choose the task from the marketplace. So as we choose the images in the VM, so while creating a VM, we choose the images, right, from the marketplace. Here also you can choose different tasks from the marketplace. You have to choose the task, what task you have to perform. So there are many kinds of tasks. For example, if you have to deploy something, then there is a deploy. Okay, so deploy, you can say deploy Azure app container. This is for example, this is just for example, Azure app container. This is a task. So inside the job you have task. Then there is you can have a PowerShell task. Now in this PowerShell task, what you will do? You will write some PowerShell script. So there is a block provided here. You will write some inline script over here, inline PowerShell script, which will run inside that agent. So you are writing a PowerShell script here. Small script, okay. So very first, you can say building block is agent. Second is jobs. Inside the agent, you have different jobs. And then inside the jobs, you can have task, many tasks. And task, you can say, it's a basic building block of a pipeline. So first you can have agent like this. Inside the agent, you can have jobs. So you can have job 1, then you can have job first. Like inside this job, you can have task. Then again, you can have a other job, right? Job number 2. Then again, you can have task inside that. Number of tasks you can have. So like this, you can frame a pipeline. Now, a pipeline can be created like 2 types. Classic pipeline, classic editor. Now this classic editor is nothing but a UI interface. You can choose and add and create a pipeline. Classic editor. We will see later on. As of now, just we are getting all the things, okay, into picture. So classic editor. So there are 2 types to write a pipeline or create a pipeline. 2 types to create a pipeline. First, you can use classic editor. This classic editor is nothing but a kind of a UI interface. Like portal is a UI interface. From there, you can directly choose using your mouse and all, and you can create resources. Similarly, classic editor is a UI interface. Second is scripted pipeline. Why I'm saying scripted? Because this is called as a YAML pipeline. You have to write in YAML language. You have to write the pipeline as a code. So YAML pipeline. In the YAML, you have to write pipeline in script form or code. Write pipeline as code. Don't misunderstand code. I'm just saying like script, okay? Some script. And this is YAML format, .yaml. Whatever the file you will create, it is in .yaml. So you can write as YML. Also, you can write as .yaml. Both are same. YAML is yet another markup language. So 2 types you can create a pipeline here.
So,
Similarly,
Abhishek,
Mhm.
Abhishek, I have one question here. Like
Mhm.
apart from YML file, we can use any other file type.
Any other file means?
Any other file type in like
No, YAML only.
scripted pipeline. Yeah. Only YAML.
YAML, yes.
Okay.
Okay. So this is similarly, you can create a release pipeline also. So build pipeline, when you build something, so here you are building a .NET, you can say project or something. So after building, what you will get, so once you build the project, so you will generate the artifact, right? You generate some DLL files and all from the .NET package. So generate the artifact. So these artifacts will be used for when you are deploying your application. So for .NET project, there are different artifacts. You can have DLL files. Okay, all these things. So if I talk about .NET, you can have DLL, .dll and all those files. If we talk about Java, there are packages you can have like .jar, .var, .ear. These kind of packages you will have, or artifact files you can say, and you can deploy these files. Now once the artifact is generated, it's up to you how to store the artifact. So you can use artifact repositories also. So first you can store artifact with pipeline agent. Second, store artifact with first in the our pipeline agent, then others you can have artifact with, say, example, you can store it in a file storage, Azure file storage. So that, say, file storage is attached to your VM, pipeline agent VM. Okay, so there you can store. So that is an external storage. Okay, Azure file storage. It will be stored with your storage account. Okay, so you can have your artifact with the pipeline agent also, and you can have it with external storage also, like Azure file storage. So you can have that with a storage account. Storage account comes into picture. Or either, what else? Another example, you can store it with a artifact repository. Artifact. Now there are many artifact repositories, for example. So artifact repos. There is very popular one called Nexus. Nexus artifact repository. Now, since these are enterprise ones, Nexus and all, you have to integrate these things with the pipeline. You have to integrate these things. Then only you can use Nexus repository. So it totally depends on the organization. So earlier, when I used to work in AWS, like before 2017, so there we were using this Nexus artifact repository. Okay. So in a Linux server, we have installed this Nexus artifact repository, and we used to keep our artifacts with the Nexus repository. We have to, now why to keep here? To maintain the versioning. Now why you maintain the versioning? So say if you have deployed something and your product owner says, I don't like this, just revert it back to the original form, like last one. So versioning like this, you can have artifact version like 1.0 is there. Then you can have 1.1, latest one. Then you can have 1.2. Then if there is some major change, then you can have 2.0. Or you can have 2.1, like this. So you have to maintain the versioning in the artifact repository, so that if someone wants to like rollback means whatever is there feature, last feature was there, just roll back to that feature only. I don't want this new feature. So what you will do, again you will deploy with the last one, last artifact, whatever is there. You don't have to perform anything again and again. So maintaining the versioning, maintain the version of this. So artifact repository. So this is all being done, storing the artifact. Once you have the artifact and all, what you can now, you can perform a release over here. So you can have release pipeline now.
You'll save this diagram, right, Abhishek?
Yeah, I'll save it. Now you can have a release pipeline here. Same way you can write the release pipeline also. Means you can have agent here first. Then after agent, you can have jobs. And then after the jobs, you can have task. So you can write it using YAML also. You can create this pipeline using classic editor also. Whatever you want, you can do. Release pipeline, what it will download the artifact. Now, while here, what it does, this pipeline publishes the artifact. So one task you will be having here, publish the artifact. Publish the artifact. So build pipeline will publish the artifact. Publish. And also, if you want, you can have a task to store it. Store it. Now you can have a task to store with a file also, Azure file also, Azure file storage, or you can store it with artifact repo also. But if you choose to store with artifact repo like Nexus, you have to make some integration, Nexus integration with the Azure pipeline, all those things. Like, so will publish, you can have a publish task. Now, when you are having a release pipeline here, then you need to have one task like download artifact. There you have publish artifact. Here you have task as download artifact. This is a task. Very first task. Once you download the artifact, then only you are able to perform some next task. So next task you can have deploy this to the Azure container or deploy to this Azure web service. So next step you can have like this. So like this, all the workflows about like CI/CD pipeline. So versioning is there, then see here is first is version control system. Then you have this continuous integration and continuous deployment. Third
What
one,
is the agent pool? Agent is working here. How it is working? Agent pool.
here, this one.
Yeah.
So see, when you create a pipeline, say you perform any task, like you run some script, you run some command line script. So that task will be needing some compute resource, right? So if I run something here without this compute resource, without my laptop is a compute resource, how can I run this script or how can I run the command? Not possible, right? Right or wrong? Yeah, I will need some compute resources. Similarly, to perform all these tasks, to build the code, I need some compute resource in the background. That compute resource is nothing but the agent. And there are two types of agent. One, you can have Azure pipeline agent. Now this pipeline agent is some virtual agent. I don't know where it is running because Azure takes care of this.
Okay.
Second one is I can have my own agent. I can have my own agent. So now if you go here, just search for some virtual machine over here. Virtual machine. Click on create virtual machine. Leave this. Go to advanced mode. See, set an extension to install. Now just give the basic things. Just give this resource group, my VM1, okay, availability zone, each and everything. Okay, this is done. This is done. Everything is done. Next, go to next. Now go to advanced. Now select install an extension. Now I can install extension in my VM. Azure Pipeline Agent for Linux.
Okay.
Got it? So if I create this virtual machine to run some agent, so once this is created, I will make a connection of Azure portal to my pipeline, and in that pipeline I can use this agent. I can use this agent in my pipeline. So when I create a pipeline, I can have this agent, this Linux agent, agent machine, whatever the agent name, I can have that.
Okay.
So whatever the tasks are there, means once you initiate a pipeline over here, once a pipeline is triggered, all the things you can be seeing inside that VM happening. Means once you initialize the task here, the VM will be the agent where all these things, pipeline, like background jobs and all will be running. The project is creating, the artifacts are creating inside this VM. Got it?
Yeah.
Yeah. And with the pipeline, Azure Pipeline Agent, what happens? This will not be there. This will not be there. Means Azure will create a pipeline agent for you. But as soon as the build is completed, Azure will delete this pipeline agent. Only you will left with the artifact. So once the task is done, this is kind of a sandbox environment. So Azure provides some sandbox. Sandbox means whenever you are practicing something, it will create an environment for you. And whenever you are finished with that thing, it will delete that environment. So that is Azure Pipeline Agent. Okay, you got what is agent? Hello.
Yeah, I got it.
Yes, sir. So can you keep it
So
till
for
here?
every release, you need to create separate pipe agent kind of thing, or
No. I can use that agent for other releases. Like, but if you are working on different projects, then you must be having different agents. Yeah. If I developing the same different features of a project, then same agent will work. No worries. But if I'm developing different projects only or different applications, then you should have different agents.
So should we have the Linux machine has different agent and the Windows machine have different agent like that? I mean,
It
different
depends. You can choose any agent. You can choose Linux also. You can have Windows also.
.NET application. So if it is based on the application, we have to choose the agent or something like that. We have to create. Not like that.
Not like that. See, now everything is cross-platform. Okay, you can earlier you were not able to use PowerShell in Linux environment. Nowadays they have application for PowerShell also in Linux. So you can use PowerShell also in Linux nowadays. Cross-platform. Nowadays, what you can do? You can connect a Linux machine through command prompt also in Windows 11. So everything nowadays are becoming cross-platform. It's back 4-5 years back when you were not able to, you have different environments. Okay. Nowadays, everything is becoming cross-platform.
Sir, can we keep it till here? I mean, it's 9:30 to get ready for office.
Yes, sure. One or two more things, 2 minutes, right? Wait.
Okay, okay.
So version control system, then continuous integration, deployment. Then after that, you have some application servers, right? Those are like application servers we can have like when we'll be creating some basic applications. So this is the dev where you deploy things, right? Application servers. But in DevOps, like since there are two types of architecture nowadays, like monolithic and microservice, and mostly everyone is following a microservice architecture. Okay, so monolithic and microservice. In monolithic, what will you have? You will have a single code base and you will develop a application as a single feature. So application developed as a single feature. Single code base. What can you have here in the microservice?
Multi-language.
Application developed as a multi-feature. And
Multi-code.
yeah, no single code base. So when I say no means, like say you are developing an application here, for example, login page, product page. Now what happens? Some issue arises with the product page. What you can do now, each feature is having a different source code file. You can directly go to the source code file of the product page and just make changes in that product page. And you can deploy these things. And this product page will also be deployed in some other container. Okay, so different containers are there for login page, product page, card page. Okay, so your whole application will not be down because you are making changes in the product page, but your login page is still working, your cart is still working, and you can make changes in the code base of the product page. So if you have monolithic architecture, you can have like 10,000 lines of code, and it is very difficult to debug that. And here you can have multiple files here. So you can have one file like login page, 100 lines of code is there. Then you can have product page, again 100 to 150 lines of code. It is very easy to debug this. So whatever the issue with the product page, just go to this file, make changes, deploy it again to the container. Now again, like after this version control system, continuous integration and deployment, you have one more thing like containerization software. I'll not explain containers again because I have explained in, I think, lab number 20 or something when we are doing admin part, 20 or 21. I've explained everything about containers over there. So containerization software, you can have containers, right? So in our case, what we can have Azure Container Apps. Now this Azure Container App will be having many containers. Also, you can use, if you want only single container to deploy, you can have Azure Container Instance Service. container instance. Instance means only one container. So this is from Azure. These services from Azure. What is the popular one? Docker. Docker. So Docker container. So for deploying this application, so you can have a separate container for login page, separate container for product page, separate container for card, separate container for payment page. Now you say if we will deploy this separately, how we will manage the application, how we'll organize this. So for organizing the container, there is a separate application like container orchestration.
Orchestration.
Container
Kubernetes.
orchestration. In this container orchestration, you can have services like AKS, Azure Kubernetes. So first you can write Kubernetes. For Azure, you can have Azure Kubernetes. For AWS, you can have Elastic Kubernetes. For GCP, you can have GKS, Google Kubernetes. So Kubernetes was developed earlier by Google in 2005. They used for their inline purpose, inline development. But later on in 2012, they made it public. Okay. Now everyone can make changes and have their own version of the Kubernetes. So Azure is having Azure Kubernetes. Amazon is having their EKS, Elastic Kubernetes. Google is having their GKS. Oracle is having this some OKS or something. I don't know. I never used Oracle Cloud.
OKE.
Okay, yes. So all these. So you can manage these containers by doing container orchestration. So containerization software, and last one is container orchestration. And then at the very last, you can have continuous monitoring. Continuous monitoring. So in the Azure, you have different services for monitoring, but you can opt some enterprise services also. So for Azure, we can have Azure Monitor. Then we can have Azure Log Analytics. This is for log monitoring. Then for application monitoring, you have Azure App Insights. App Insights. These are in Azure. For popular one, enterprise, Prometheus and Grafana. This is application monitoring. This is for app monitoring. Then for log monitoring, you have ELK. What is ELK?
Elasticsearch.
Elastic Log.
Logstash, Kibana. ELK stack. So you can have this for log monitoring purposes. These are popular ones. Okay. So application monitoring is different, log monitoring is different. Okay. So last one is this one, monitoring. You can have some others also. Okay, app dynamics and all for app monitoring. So let's finish up here, wrap up here. Okay, I'll stop recording now.